Well, hello, and thank you for tuning in to this talk. My name is Stefan Mann, and I'm responsible for technical marketing at GAMS. Today, I'm going to talk about our new product, GAMS Engine, which is a system that allows you to easily run GAMS jobs on centralized compute resources. In the 15 minutes I've got, I will try to give you an idea of how GAMS Engine is designed and how it works, and how you can use it in your own projects. But before I'll start with this, I would like to spend a few minutes on introducing GAMS for those of you who do not know us. So GAMS stands for General Algebraic Modeling System, and is the first algebraic modeling language, and it can trace back its roots back to a World Bank project about 3 decades ago. Since then, algebraic modeling languages have proven to be really mainstay tools in a lot of areas. And GAMS has been one of the main tool providers in this area. So currently we have offices in the US and in Europe with around about 25 full-time staff. So our core product is, of course, the actual GAMS distribution, which consists of the modeling language, a whole range of commercial and open source solvers. It includes APIs for C++, Java, Python, MATLAB, and more programming languages. It also has a new development environment called GAMS Studio and a huge library of example models which help you get up to speed very quickly. So in recent years, it has become more and more obvious that the usage pattern of this kind of software has shifted a bit. So where you used to have a modeling expert who was responsible for development and implementation of a model, and then also for running it and analyzing the results, things tend to be much more collaborative these days. So we have some rather large customers, for example, with offices scattered around many countries, who would then like to share models and the modeling results between their different teams. And this, of course, calls for some kind of server-based solution. So we have developed 2 new products for this. One is called GAMS Miro, which can transform existing GAMS models into interactive web applications. My colleague Robin Schuchmann is going to talk about that tomorrow. And the other product is called GAMS Engine, which is our deployment solution that allows you to host and deploy your GAMS models on a server, on centralized or cloud resources. And this is what I'm going to talk about today. So let's look at a bird's eye view of Engine. It has some main components. The most important one for the user is the so-called broker, which provides a REST API, so programming interface that is used to access Engine, and it's the gateway between the internals and the outside world. So typical clients that would connect to the broker are GAMS Studio, so our development environment, Miro Desktop and Miro Server, and I'm sure Robin is going to talk about that a bit tomorrow. The broker also has a built-in web user interface, which allows you to add users, add namespaces, and things like that. So administrative tasks. And the topic of today is custom clients. So the broker conforms to the OpenAPI specification, which means that it is a programming language agnostic interface description for REST APIs. And OpenAPI allows the creation of interfaces for many different programming languages, such as Python, Java, C++, Ruby, and more, with a code generator that reads in a JSON file, which contains the description of the API. So the second main component is the job queue. So jobs that are submitted via the API are placed onto the queue and distributed from there to the available GAMS workers. So that's the third component, GAMS workers, which work on the jobs, and once they're finished, place the results into a database, which can then be queried via the REST API. So GAMS Engine is realized as a Docker stack, which means that we have a bunch of containers that communicate with each other through a Docker network. So we have the first one, the broker, that provides the REST API for requests such as job solve requests, query, results queries, and doing administrative things. Then we have a RabbitMQ, that's our message queue, that provides the task queuing system between the workers. It keeps the solve requests and provides a fail-safe when a worker dies, so it can redispatch a job to another worker then. Then we have a database component. In our standard case, it's PostgreSQL. That keeps the necessary information for the solves, user information and logs. We have a file storage component that keeps the model data. And of course, we have the worker, which grabs jobs from the message queue, solves them, and then places the results into the database. So all of these containers are, as I said, in an internal network, and it's only Nginx, which is a part of this broker container, that listens to an external port and exposes the broker to the outside. So this whole Dockerization has quite a few benefits. For example, one common requirement is that the workers need additional capabilities, for example, additional Python packages or other third-party software. And we can easily modify the Docker images for the workers to include these additional components, as long as they can run inside a Docker container. Also, if you want to swap the database for something else, that's easily done. And another benefit is that we have this automatic failure detection and recovery. So if a worker dies for whatever reason, a new worker will be spun up and the job will be restarted by the RabbitMQ system. Finally, we have horizontal scaling, which means we can have as many workers available as we need, of course, always within the limitations of the underlying hardware. Now I would like to share with you how simple it is to create a custom client for GAMS engine. And I'm going to create a Python client for this and show you how to solve a simple model from the GAMS library. A few prerequisites have to be met for this to work. So we need to have a Linux server, which has to have Docker and Docker Compose installed. We need to have Python 3, a Java runtime, and Node.js installed. So now I'm going to show you how to do this. So we have detailed installation instructions on our website. First, you need to have a GAMS engine zip file, which I have here, which we need to unzip. That creates a folder called GAMS engine. We can change into this folder and call the script .up.sh. So that script will spin up the Docker network. We need to give it a port number to listen to. I'll always use 8888, and the number of workers, which I'll set to 4. I could also add key files for SSL encryption, but I'm not going to do that for this example. And of course, I need to do this as sudo. So now the system is going to be installed. We're currently pulling the images from the Docker repository. We've created an internal network, and within a few seconds, the whole process will be done. Now we're done. At this point, we can see if we can access this newly installed engine installation. And yes, we can. So the standard password is admin. So admin. Now we have to update the license information because GAMS needs to be licensed. For engine installations, we always have 2 components. One component is for engine itself, and the other component is for GAMS. Let's quickly copy that in here. So now we have our system licensed. I will quickly change the standard password to something other than admin. And then we can log in again to see if the password change has worked. Yes, it has worked. Currently see that we only have one user called admin, which I'm going to use for this example. So After we've installed Engine, we need to install the OpenAPI tools. So this is the toolchain that will generate a Python API API client that we can use to access Engine. These two commands here, which are part of our website documentation, I have already run in the background because they take a few minutes. But the next command we can do together. So it's going to install it's going to perform the installation or creation of a Python interface. So we need to tell it where to find the API definition. Oops, I'm in the wrong folder. So here we have to go. So again, npx so generate, take the JSON file that contains the definition of the API, generate a Python version. Output path is the local directory, and the package name is supposed to be GAMS engine. Now this will run a few seconds. And now that's done. So the Python API client is generated. I have prepared a Jupyter notebook to quickly walk you through usage of the API. So I will start. Jupyter notebook. Example is here. So to use the library, we first need to obviously import it. We need to import the GAMS and the GAMS engine package and the GAMS engine API, jobs API. Then we need to create a GAMS workspace and assign a model to this workspace. So we're going to use the transport model from the GAMS library. The model needs to be submitted to Engine in the form of a zip file. So we'll do this step here, create this zip file. Then we need to add some configuration variables to tell the API client where to find Engine. So we're going to use localhost 8888/API. The user is admin and the password is this. And we need to also tell it which namespace to use. So global is the only namespace we have available at the moment. Execute this. Then we need to enter a context with an instance of the API client. We create a job API instance here, and then we're posting the model to Engine by issuing this command, so the create job method, and we pass in the model, the namespace, model data, and command line arguments. Whenever you submit a job to Engine, you will receive a token as a response, and this token is a unique identifier that identifies the job on Engine, so you can always access it later. Then we will wait for the job to finish and print the standard output. So you can see it looks exactly as if it would, as if you had called GAMS from a Linux command line. You can see its model's been solved. We have an optimal solution with a result of 153.675. Now this is just the output on the command line. Of course, we also want to get the model results, which we can download as a zip file from Engine. We'll do that here. And this zip file will contain a GDX file, which contains the model results. We'll delete the model results from our server so we don't pollute the namespace. And then we add the results to our local GAMS workspace and go through the results and print them out here. So that's all you need to do in a very, very fast forward way to use GAMS engine from Python. Now, the benefits of doing it this way is obviously that you can use much more powerful server hardware instead of your local PC or laptop. You have a built-in job scheduler with a configurable number of workers, so 4 workers in our example here. The clients can do other things or even go offline and fetch the results later. So especially if you have your laptop, you can schedule a very large job that maybe runs even overnight, but you can close your laptop and go home. And especially useful for commercial customers, we have centralized license management. So instead of distributing GAMS licenses to all affected people who need to use the system, we now have a centralized system that has one license and everyone can use that. Now, the system I have just shown you runs on a single server and has been available for a little while now. And currently, Burak and Freddie are working on turning this into a cloud-based system, which will be available very soon. So this system will be operated by GAMS and will be almost limitless in terms of scalability. So the number of workers can be very, very large, and you can then solve a large number of jobs concurrently. And with that, I would like to thank Burak, Freddie, and Robin for their great work developing GAMS Engine and Miro. And thank you for your attention. And don't miss Robin's talk tomorrow. Thank you.